Hello, my name is Hanjun, and today I'll be going over my lab report for Lab 1, Constant Velocity of Physics 2211 at Georgia Tech. So today to start the lab report, I'll be starting with introduction, the purpose of lab, Newton's second law, and then going over initial conditions, and the procedure, and the two models I will be comparing, and I will end with discussion and additional questions. The purpose of this lab is to observe and compare two models of constant velocity using Newton's second law. The first law model, which I recorded, uses a CeraVe 1 fluoro ounce bottle, which is empty. I rolled it across a table with constant velocity, and the other model that I tried to predict the object's position by using GlowScript code. And here is a brief overview that object's actual velocity was not completely a flat line, and the predicted velocity was higher than the actual velocity. Newton's second law is the principle that I'll be using in this lab report. It is also known as the momentum principle and states sum of forces equal to mass times acceleration and describes the changes in momentum in the system caused by external forces. There's no net force acting on the system. That means there's no acceleration and the system velocity stays constant. As we can see in the position and velocity update formula, if the acceleration is 0, acceleration times time will be 0, and the final velocity will be equal to initial velocity, which means there's no change in velocity. If there's no change in velocity, the update of position will be constant. Some initial condition assumptions include air resistance and friction are negligible. Surroundings are the table, the air, and the hands. The system is a cylinder only, and initial conditions that cylinder is already moving with velocity and the net force acting on the cylinder is 0. Experiment. So I first started recording the video, and then I graphed the position versus time graph in Tracker using this graphing tool. I have to graph like data points, and you use GlowScript starter code to graph a predicted position versus time graph by calculating initial velocity using time and displacement traveled. And then I graphed both data in Google Sheet, and then I compare those two. Here's a video of my observation model. So here's a graph of my observation model. So as we can see, it is going the next negative x direction, and it has a relatively constant velocity. Here are some calculations of my observation model. We assume that there is 0 air resistance and 0 friction. Initial position is this. Initial velocity is calculated using delta x divided by delta t of the first two data points in my tracker. And the time to reach the end of the table is 2.6 seconds. For a computational model, I didn't use the position update formula since we assumed there is no net force involved, and then I just got rid of the 1/2 AT squared part, and then I used d final equals d initial plus vt formula. I also assumed net force is set to 0, and then predicted initial velocity to be negative 0.54 meters per second. Discussion. Tracker's position is changing at a slower rate than the GlowScript model, meaning that there has to be some type of outside force that is slowing the cylinder down, and the starting positions are different, possibly due to human error. Some errors include human error, rounding error, and early assumptions such as no friction and air resistance are technically false. Therefore, there is external forces slowing the object down. Additional questions. What if? The cylinder's direction of velocity will become positive if I change my negative x direction into the positive x direction. Last question. What does it mean? We can't achieve a graph like a computational model because there's simply too much external forces in my experiment environment. It's not perfect, meaning that in the human environment, there has to be some sort of external forces, and simply isolating the system to the object itself doesn't get us the desired result. Thank you.